Okay, everybody, today we're starting our new unit on trigonometry. Been waiting for us to get to here, so we're about halfway through the course almost and getting into trigonometry. So a couple things you need. You need your graphing calculator. There is a worksheet online, a notes worksheet. If you have a printer, it would be great if you could print it out. If not, just have that open on your computer off to the side, and you can refer to it. So you can take notes in your notebook then. If you are doing that in your notebook, you want to title your notebook Lesson 5.1, Angles and Degree Measure. Otherwise, if you can print that worksheet, that'd be great. So before we get into some trigonometric functions, which we'll do tomorrow, we need to explore a little bit about angles and degree measures. Because you've had some experience back in this in geometry, but we need to get a little bit more specific about some things and some standardization that we're going to do in terms of how we measure angles, where we measure angles from, and so forth. All right, so again, as always, you can pause me at some point. You can back up if you need something repeated, but let's go. All right, so a couple definitions here. So angles are two rays joined at a vertex. So that's my picture over here. So two rays that would go on forever from a vertex. And we measure them in degrees, minutes, and seconds, which we'll get to in a little bit. But most of the times you might say, oh yeah, this is like a 20-degree angle, or maybe a 20, it could be something like 19.85 degrees. Well, there's other ways that we can measure more specifically down to degrees, minutes, and seconds. If you have your note sheet, so you're putting this definition down. We are going to standardize how we are drawing our angles. So the 0 degrees is always here to the positive x-axis. And I'll show you about negative and positive angles in a second. Standard positions always have their initial side right there on the positive x-axis. So positive angles are measured counterclockwise, and negative angles are measured clockwise. So what you might be exposed to already, you want to get those definitions down on your notebooks, in your notebook or your notes sheet. So in here's I have two little pictures on the note sheet. Here I'm starting at the positive initial x-axis, and positive angles would be coming up and around, and negative angles would be going down. You want to give little sketches of each of those. So my question now is, what would be 3 clockwise rotations? So clockwise, so I'm going to be going with the clock, so that's going down 1, 2, 3 times. What is that angle going all the way around? 3 times clockwise. Well, each time that I went around clockwise, remember I was going down, that was negative. 1 rotation would be negative 360 degrees. And I'm doing 3 of them. So 3 times negative 360 on my calculator, I'm getting negative 1080. Have we ever heard angles like that before? Going around a couple different times? Yeah, things like maybe in sports and, skateboarding, snowboarding, doing twists and turns. 360 is 1 revolution, 720 is 2 revolutions, 3 revolutions is 1080s, but we're going in the negative. Well, what if I don't want to go all the way around? What if I want to do 2.4 counterclockwise rotations? What would that maybe look like? So I'm going around backwards. There's once, twice. 2.4 is a little shy of 2.5, so maybe somewhere there. Terminal side would land somewhere there. So now I'm going positive 360 because I'm going in the counterclockwise direction, and I only went around 2.4 times. So 2.4 times 360 on my calculator, I get 864 degrees. So reference angles, these might be some of our most important things that we're going to be dealing with. Is the reference angle is a positive angle formed between the terminal side, this is my terminal side here, and the x-axis. So it's always positive and acute. I think I might have missed this on my note sheet. If there's that little line there, I would put this definition down because this is going to be pretty important for us. So I've got three angles here that I want to find their reference angles for. So I've got three little diagrams on your note sheet. So 150 degrees. All right, so 150 degrees starts at the positive x-axis. It's positive, so I'm coming up around. Here's 90 degrees. And now 180 would be over here if I went around. So I'm shy of 180. So I'm somewhere here. So this is the terminal side. So the reference angle is the acute angle between the x-axis and the terminal side. It's that angle right there. Well, if I've come around 150 degrees, how much further to get to 180? Well, that means I have a 30-degree reference angle. That's that angle right in there. What's my next one? Now I'm going negative 315. So negative 315. So I'm going to come around. So here's negative 90. Here's negative 180. Negative, I'm going clockwise. Then do you know the next one? It's going to be 270. That's 90 degrees past 180. I need to go to negative 315. So I'm all the way over into here because I haven't gotten all the way backwards to 360. So I'm trying to figure out this angle right here. Well, I've almost gone all the way to 360. So if I simply take 360 minus 315, how much was left over? Well, that's 45 degrees. This angle inside of here is 45 degrees. Now, even though I went negative 315, the reference angle is always a positive angle, and acute obviously meaning less than 90 degrees. All right, you want to try 225? Pause me and see if you can do that one. So 225 is positive, so it's going to come up. Here's 90, 180, I don't want to go all the way to 270, so it's somewhere right in here. And my reference angle is going to be this little angle right in there. So how do I figure that out? Well, I've already gone 180 degrees. I just need to know how much more to go. So 225 minus 180. Well, look at that. It's another 45-degree reference angle. That's that angle right in there, 45 degrees. So we're going to be figuring out lots of reference angles here over the next couple weeks here. All right, easy enough. Next, quadrantial angles. Well, those are the angles that we just started talking about. So I got 4 pictures for you and a definition on your note sheet. So they're angles whose terminal sides lie on the axes. And so that's going to be our 90-degree angle coming around 180 degrees. Now this is negative 180. Positive 180 would come around that way. 270 degrees is 3/4 of the way around the circle, and obviously all the way around is 360. So get those pictures and that definition down in your notes or the note sheet page. Coterminal angles, another definition, so jot this down. Angles which differ by 360 and have the same terminal side. So I want 3 coterminal angles to 30 degrees. So I'm going to draw, like I got a little picture there on your note sheet. First of all, here's 30 degrees. It's positive, so I went up to sketch it. And now I want to find 3 angles coterminal to it. Well, meaning that they terminate at the same spot. So right there, I'm going all the way around the circle. So that's another 360 degrees later. So 30 plus 360. So that's 390. So 390 is coterminal. It'll stop at the same place that 30 degrees did. Could I go around again? Sure. So I could take 390 plus 360. And calculator handy, 750. But hey, that's not interesting. Let's go backwards. What if I started at my 30 degrees and instead, here it's coming out here, what if I went to 30 degrees and went backwards 360? So 30 going backwards 360, and that's going to be negative 330 degrees. So as long as I'm either adding or subtracting 360, I can get a coterminal angle. So 150, where's 150? Well, it's positive, so it's going to come up around 90. It's not going to go all the way to 180. It's going to be right there, 150. Okay, it has a reference angle of 30 degrees, but that's not what I'm interested in. I'm interested in coterminal angles. Angles that, if I go around, I get another angle that stops at the same spot, so I could add 360. So 150 plus 360 is 510. You can go again around, keep going positively around. Gets a little crazy to draw it with all those kind of concentric looking circles. But don't forget, you can also go backwards. So I could take 150 minus 360. That would be this angle going backwards 360. And what's that turn out to be? Oops. And 150 minus 360 is negative 210. So coterminal angles, super easy. Just adding or subtracting 360. They're angles that stop at the same place, terminate with the same terminal side. Right, so now this is getting into what I mentioned at the very beginning, is that angles specifically, we always think of them in terms of degrees, but when you start talking about big angles, that can get very precise in terms of its decimals, like latitude and longitudes of the Earth. So we get more specific. Instead of throwing all those decimal points in, we can talk about degrees, minutes, and seconds. So picture this. If I have an angle, if I open up an angle, and let's say it is simply 1 degree. It's really small, just 1 degree. Well, what we're saying is that we can break that 1 degree up into 60 different smaller little angles inside of it. And one of those little angles, it's 1/60th of a degree, but that measures 1 minute. That's 1 minute. Then if I take this 1 minute and break it up into 60 little different parts, each one of those little parts is 1 second. So let's fill in a little chart down here. We're on the back of the worksheet. 1 degree has 60 minutes in it, so you can almost think of a degree as like an hour. And then 1 little minute, like I drew over there, that's going to have 60 little seconds in it, which is the same as time. So therefore, 1 degree is going to have how many seconds? Well, 60 minutes in a degree and 60 seconds in a minute. That means there's 3,600 seconds. So this big angle right here would have 3,600 little tiny angles inside of there, and that would be 3,600 seconds. Well, if I go backwards, 1 second is 1/60th of a minute, and 1 second would be 3,060th, 3,600th, I should say, of a degree. And we can use those ideas when we're going back and forth between converting between degrees, minutes, and seconds, and just degrees as a decimal. So let's take a look. So in this case, let's practice here. I don't have this. You can use the space down on the bottom of the notes sheet, down at the very bottom. So I took Gettysburg Area High School and just went and used a compass and figured out where we are. So in terms of the Earth, we are around the 39th, almost the 40th parallel north. So we're 39 degrees north of the equator, and we're 77 degrees-ish west of Greenwich Mean Time, the prime meridian, over there in Greenwich, England. So let's convert one of them. Let's say we're going to convert our latitude. So 39 degrees, 51 minutes, and 12 seconds. Well, that 12 seconds is how many there's 12 seconds in a minute, so I have 39 minutes, 39 degrees, 51 minutes, and then to that 51 minutes, I can add 12/60ths to get my total, I'm using my calculator, number of minutes. So I'm taking 12 divided by 60, which is 0.2, so I get 39 degrees and 59.2 seconds. Well, now I can take my 59.02 and divide that by 60, so I can do 51.2 divided by 60, So 51.2 divided by 60. And add that to 39, so I get 39.853 repeat. So 39 degrees, 51 minutes, 12 seconds is equivalent to 39.853 degrees. Don't forget my degree symbol. You want to try the other one? So 77 degrees, 13 plus 11/60 minutes. That's a pretty ugly number. So it's 77 degrees, 13.183 repeat minutes. Now I'm going to take that and add 13.183 divided by 60. Add that to 77, and I get, it's degrees, 77.21972 repeat degrees. Don't forget the little degree symbol. That many degrees. So it's going from precision in terms of degrees, minutes, and seconds to just degrees. Let's triple others here. So what if we go the other way around? All right, so let's think about it this way. I'm going to have a certain number of degrees, minutes, and seconds. Degrees, minutes, and seconds. Well, right away, I know I have 52 whole degrees. But then I have 0.125 degrees. So I'm going to take 0.125 and multiply it by 60 to see how many minutes that is. And I get 7.5. So that's 7.5 minutes. Well, that means I have 7 whole minutes. Well, 7.5 minutes, we obviously in our head know that's 7 minutes and 30 seconds. But let's just see. I already counted for the 7 whole minutes. Let's take 0.5 minutes, multiply it by 60, and there you go. There's 30 seconds. So seconds get 2 tick marks, minutes get 1 tick mark, and degree gets the degree symbol. So you want to try this one? You can pause me and try converting for yourself. So it is possible to have seconds in decimal form because that's as low as in terms of the smallest measure that we're going to wind up using. Now if I go backwards, instead of multiplying by 60s, I'm going to be dividing by 60s. So I'll first take 3 divided by 60. I get 0.05. So what I have is 13 degrees, 5 minutes. Oops. Let me erase here. Let me do something here to make it a little bit easier for us to see. So I've got 13 degrees, 5 minutes, 3 seconds. So then I'm going to take 3 divided by 60, which is 0.05. And so that means I have 13 degrees, 5.05 minutes. Now I take 5.05 and divide that by 60. And I get a really ugly number, 0.8416. Repeat, and so then I add that to the 13. So there's 13.08416 repeat degrees. So I'm going to go over to here to do this last one. You going to try it on your own? So 15 divided by 60 is 0.25. So what I have is negative 310 degrees and 55.25 minutes. So 55.25 divided by 60 is 0.920, so I'm going to get negative 310.92083 repeat. Which, if you think about it, that makes sense. It's almost at 300 and, let me put the degree symbol at the very end. Almost is 0.9 means that I'm almost to the next degree, almost at negative 311. And if you look, it was 55 minutes, which is pretty close to 60 minutes. So I'm almost to that next degree. That makes sense. Well, this is a lot of calculations. There's got to be an easier way on my calculator, and there is. So on our calculator, there is a button hidden in the angle menu. Now, the angle menu is above the apps button. So on your calculator, all you have to do is to type in 52.125, don't need a degrees symbol, and then if you go into the angle menu, which is above apps, the fourth thing down says change to degree minutes seconds, DMS. You can see over here on the left, it changes it and converts it exactly what we just saw earlier. Try the next one. Put in 87.234, second apps, the angle menu, change to degree minutes seconds, and you should get that answer. There are ways, and if you look in the angle menu, there is a little degree symbol and a minute symbol, but there isn't a seconds symbol, so I just think this one's pretty easy. And if you look over here to the left, these are the same steps that I just did on the graph that was before, or the chart that was before. So at this point, now go back to the daily page. I got some practice problems on a worksheet for you to solve. Make sure that you're practicing these. These are all foundational things that we need for the rest of us, our work in our trig unit coming forward. Make sure you're asking questions either in class on Zoom or via email. Okay, good luck.